Well, a very good day, everybody. Now, a lot of you know that I put together this homebrew mast. The whole idea behind this mast, I like to call it a tower, all right? If you want to be pedantic, you know, call it what you want, really. Which is a bit of a hassle, but you have to appreciate it's completely prototype, homebrew, a bit at a time. So, you know, we were using what we had lying around at the time, just to see the practicalities of it and what it was like. Because to be honest, I'd been on YouTube to see who else had done this. But we used a falling derrick, which is the bit that goes from the base of the tower to, well, roughly about here, to be honest. It was 6 meters long. And that's the bit that goes up and down and drops the whole tower. So if you were thinking of doing this, I've got some tips for you. I've also got a ton of questions and advice that people were giving me, and why didn't I do this and why didn't I do that, and you know, so I just thought I'd run them through, and I made some notes here. So the first thing people want to know is why wasn't I wearing gloves but a hard hat? Because if you look at industrial accidents with clothing, they're normally a lot worse than without clothing. In fact, I know a man that went around a machine. I don't know him, sorry. My next door neighbour was the managing director of a company in France, actually. He got caught in this huge machine. I mean, he was pulverised. Unfortunately, he was still alive. I say unfortunately because he was a bit of a mess afterwards. That was all to do with clothing. I'm not saying you can't have an industrial accident, you know, without clothing, but if you've got a glove and you're holding a piece of rope, and all this is prototype stuff, all this rope and stuff, and I trip and fall, and I want to let go of the rope and just let it crash down, and I'm wearing gloves and the gloves get caught, then I get dragged up and all sorts will happen. So that's why I didn't wear gloves. All right, what was the other thing? The slot that I created at the bottom of the scaffolding pole, people were saying the whole thing's going to snap and break and everything else. So this slot was an idea I had so I can put the Coax cables up, so I didn't have to go round 3 different thrust bearings, because I designed it with thrust bearings, okay? A lot of people would say that that's a weak point. Well, of course it's a blooming weak point. But if you look at the diameter of this pole, and it's 4 mil steel, I think, the diameter is 48 millimeters. So if you multiply that by pi, 3.142, let's say 3, it's going to it's about 155, 160 millimeters all the way around. And I've cut 20 millimeters of that out. Yes, it's going to be weaker. It's still going to be stronger than any rotator I can probably put down here. And you've got to remember that there's only downward force here. People seem to think there's a twisting force or there's some sort of pivot movement here. It's on a hinge, a massive hinge, just down here. So I'm not worried about that slot. I'm worried about other things, but not the slot, right? Because there's plenty of other stuff that could go wrong. Right? You've got to remember, I've got 12 guy points here in total. I only need one of them to fail for whatever reason, and this whole thing's coming down. Right. Next thing, the lines will be changed. Okay, so you've used the wrong rope. We know. This rope costs me, I think I can get something like 100 meters of this rope here for about £20. Because people don't follow along and they just jump in. They don't realise that this will be changed to a Marlow Dyneema. I think they call it trailer rope actually, but it's a 6. I've tested it, and Andrew, the sales director, and I have been talking. I'm going to get 100 meters of 6 mil Dyneema. But I don't know how long. It's really expensive. It's more expensive than blooming Coax. I'm not quite sure exactly how long it's got to be. So I'll start off with this cheap poly rope. Then I'll move to Dyneema. So if you did this, by all means, prototype it with, you know, the cheap poly rope stuff, but then go to a proper Dyneema type rope, which is a non-stretch. It's kind of like steel in that respect. Right, you're going to break your G450, the rotator. I might do, you're right. Because this whole thing was designed around an RC5-1, which we broke on the first outing. Okay, so I found a jobbing weld. I'm going to get all the bits actually welded and ground back to spec. The downward force of a G450 on maximum spec is 200 kilos, permanent load. And I've worked out that each of these lines is probably between 10 and 15 kilos downward force. I know I'm on the limit, all right? The spec of an RC5-1 is 400 kilos, which is why I'm quite keen to get that RC5-1 back in operation. And the other thing is, people think that there's somehow a lot of force on here other than downward force, but when this thing tilts over, I want you to think about it. When it tilts over, you've only got the weight of the bottom of the scaffold pole, which is about 20 kilos, just resting on that rotator as it comes over. It's not forcing the rotator over, it's on a hinge. Okay, so chill out about it. I'm using some cheap, I think they were $8, £10, 6-way pulleys, okay? Because that's what I had lying around. I wasn't going to buy anything else to raise this up and down, right? I'm surprised they didn't break, but I'm impatient. I have ordered something at £29, I think. In fact, I got a set of 2 for 44 quid. The original ones from America, Amazon said had got lost, so I'm not going to have them. And people are saying, oh no, I mean, you know, you can get marine pulleys and stuff. Well, a quad block, which is an 8-to-1, possibly depending on how the last pin is arranged, 9-to-1 pulley system. A reasonable stainless marine one is in the hundreds, okay? I'm not paying that, okay? Particularly when we're probably not going to keep the pulleys for long term either, because chances are I'll put some sort of single pulley there, and over here somewhere we'll put another, you know, big piece of concrete and a 12-volt trailer lift or something on the winch front, okay? Because this needs to get to the stage where if I want the tower down, it just comes down, no effort. But to get to that stage, we start from somewhere else. Where's your help? You didn't have any help. So I just want you to really ask the question. If I had help to put this thing up and down, what would the helper actually do? Okay? Don't get me wrong, I've put up 100-foot towers before, where what we like to do is have one person doing the lift and one person watching, because it's very tall and you just need, you know, something watching. And that was a club rule we had. I'm on my own. Very often I'm doing this during the week. You know, Mike, Jonathan, Tom, they're all working. And even if they come down, all they could do, frankly, is stand at the other end of the field. And although I walked under it a couple of times, I didn't walk under it like without listening to it, without understanding where all the tensions was. Yes, I did walk under it. They couldn't do anything. I mean, Lockie was out here and all he did is film, you know. And then when I really pushed the question, like, okay, so what would they do? What would they really do? What would their job be? And the consensus of opinion is that second person, the only thing I could probably do is call for an ambulance. Edge trim. Don't worry, I covered that. We are going to get some edge trim for this, all right? We'll sort it out, make it look pretty. I'll put some Galvafroid on it, whatever, and well, just to make it look nice. Okay, so don't worry about that either. And just don't stop worrying about the strength of it all. If it comes down, it comes down, right? One of the reasons I got the field where it is now, which is out the way of the dog field, is if it comes down, the only thing it can hurt, well, it's either me, but the chances are I'm not standing under it as it's moving. It will hit a fence, okay, and it will take some of the fence out. Can't hurt a person. The music, well, it's listed in the description. Twisting pulleys. The reason the pulleys twist, by the way, is that I've got a kind of one point here that I connected down to the falling derrick. Because it's prototyping, I need to extend the length of the falling derrick so it is literally next to here. So I lay the falling derrick will go here, and then I'll unclip these and put them on the falling derrick, and then I don't need a single point here. If you put a pulley from there down to there, I actually had a piece of rope as well. then the pulley will twist because the pulley rope was twisting. But if I connected that directly to a shackle, chances are I'm not going to get any twist. Anyhow, that was just all about... My phone's shut off. It's all about prototyping, understanding how it works, and by me doing it fairly safely. And I had the time. Then when you do it, it'll be fairly safe for you. But I would prototype it with pulley rope first, and then upgrade it. Because what I can do is I can connect all the upgraded rope to every single guide point, elevate the whole thing with the pulley rope, and then connect each of the expensive guys one at a time, and just get the right length before I then disconnect all the pulley stuff. You're still worried about the rotator? Don't be. Detuning the mast from 40 metres. This is an experiment. When I realised that the mast will have guy points roughly 6 metres away from the mast, I thought by just extending these guy points out by another 1.5 metres, about 4 or 5 feet, I could turn them into a 4 square. Right? However, it is fairly obvious, certainly to me, that that mast there will get right in the way of a 40-metre array. I calculated that a single scaffold pole insulated from the ground will put the resonant frequency of the mast at 25 megahertz. At the moment, I've worked it out because it is actually physically connected to ground, because I haven't got any insulator just above the rotator. I've worked out it's about 9.5 megahertz, which I believe may be far enough away from 40 to be relatively invisible. It will still cock the pattern up. So I'm quite keen to do is put another fiberglass insulator. Well, I'll put a tiny bit of steel in, then a coupler, fiberglass insulator about here, and up she goes. I'll show you a picture of the fiberglass insulator further up. That'll get me up to about 12 metres. I don't give a shit about 12 metres because that'll be on a quad up there or a vertical over there. It just doesn't matter. Yes, the Yagi is tilted by about 2 degrees, 1.82 degrees. It doesn't matter. It's just one thing I didn't check. It's so big when it's on the ground. That's fine. Next time it comes down, I'll just straighten it up. So if you're a bit like me and you've got a bit of OCD and it pisses you off, don't worry about it. It doesn't make any difference to the DX. Do the cables and the PoE make any noise? You know, because it's right next to the coax going up the tube here, because we've got a camera at the top, you know. So there's the PoE, there's the coax. We got much heavier coax to put up here eventually, but no, it doesn't seem to make any difference at all. Will the coax and the power over Ethernet cables, are they gonna get in the way of 40 metres? Well, I'll measure it and make sure they're not a wavelength or a fraction of a wavelength or a quarter of a wavelength or half a wavelength on 40 metres. If I have to, I'll add another like 10 metres or something to make sure it's not possibly resonant. Some people have put chokes, huge chokes, you know, like here. And then if you put a huge choke there, that'll kind of disconnect, if you know what I mean. The field at the moment is looking a bit cluttered because we still haven't connected physically the 4 square. I've got these connectors on. They're the verticals. I haven't got the radials down yet. Once all the radials are down, we can then take all the elements off and one at a time tune them all for 7.175, I think I'm doing it at. And then cut the 4 phasing lines, because I've got the box of tricks in the middle here. So I'll just show you. That's the Comtech 4 square that DX Engineering sent me as a gift. Right, underneath there we've got various connectors and stuff. Hopefully you can see that. It's over there somewhere. All the SA239s. So all of a feed coming from the cabinet over here, 50 ohm feed to the centre, and then 4 75 ohm lines to each of the verticals, less the velocity factor. And it's Messi and Poloni 75 ohm. It's exactly 85% velocity factor, which means all the phasing lines need to be 8.88 meters long, which is really handy because from there to one of these is just over 7.5 meters, something like that. So a little bit of spare, which will just coil up somewhere. Even put a choke on it. I don't know. I should see how we get on. So, problems that I've spotted that no one else has spotted, okay? Which is in order. There is, every guy line is a fail point, every one. okay, which is why I kind of went a little bit overboard on the scaffold pole, and that's down about 3 feet in the ground, lumber concrete, and this, completely overboard on this. I will actually keep that thread, I think it's quite handy. So Rick eye line is a failure point. I've then gone around, being a musician and a drummer, I'm very good at tension for heads, so I can go around my hand and I can tell you what tension all these are. As long as they're all the same, I'm fairly happy. So we've got that. Then we've got the thrust bearings. The thrust bearings are single point failure as well. They're just on shackles, and it's a friction. It's not a friction fit. It's kind of a friction fit in that there's 8 bolts gripping the pole. So we've got 3 of these. If one of those slips, it probably wouldn't be too bad. It would probably only slip a couple of inches and kind of stop, but it's still a failure point. We've got a shackle up there as well on each one of these. One of those shackles fails, chances are the whole lot's going to go over, particularly the bottom one or the top one. The other thing that nobody spotted was that on the way up, as you're elevating this thing, the far guys are loose, which means it's possible, how to explain this, that it could go banana shaped and then collapse in on itself. So in other words, it could come to the middle bit, could come towards me exactly, funnily enough, where the insulator is for the middle. So one of the reasons of going very, very steady is you don't put any shock in the system for it to banana and collapse the wrong way, where there's no weight basically holding it back. The other way of doing it is to, I mean, it's just too expensive, is to bring all the guys down to a point to other winches so that actually you've got tension on all 12 guys. Doesn't matter whether it's halfway up, a little bit up, or all the way up. But I'll try and get this shot now, because if I intentionally wobble this tower, hopefully you'll see, I'll give it a good wobble, you'll see the top kind of stays still, which is quite nice. So the whole thing, it does, I've got like a 1/4 inch, 1/2 inch, maybe 12 millimeters wobble, you know, but at the top just seems to be stable. When I had the 2 guys, when we were really prototyping it, there was far more wobble. I think 3's fine. Oh, last thing is, and I promise you this is the last thing, some people say that I've got the Yaesu rotator bearings on upside down, and they weren't designed for that way. Now, the paperwork that come with a G065, I think it's called, which is the heavy duty, slightly upgraded one, can be fitted the way I've done it. Can also go in a rotator housing with downward force, not upward force, if you know what I mean. And I think if you took one apart, you would spot how the bearing surface is, and you've got the 2 layers of ball bearings. So in other words, you can have either force going that way or that way. It really doesn't matter. But there's 2 or 3 people who are absolutely insistent that I've got the thrust bearings on wrong, and I shouldn't be using them in this application. But even on the paperwork that comes with it, if I can find it, if not, tough. It's actually got, you know, this system, and we've done it before, right, as a team, the M0XXX team, when we were a contest club, you know, and we were active and did a lot of field days and stuff like that. If you've got any comments, constructive comments, or you are genuinely interested in doing something like this yourself, that's fine. This is 45 feet, which is 14 meters. I'm genuinely putting about another 3 meters on it eventually. Sorry, 3 feet, 1 meter. And Messi and Poloni, I've been talking to Stefano. He wants to support this project. He's sending me some extra Berryflex 13. This is genuinely buriable, waterproof. So EcoFlex 15 is not, over a period of time, waterproof. What he's sending me is. So we're going to put VHF and UHF up there. So I'll have 3 dB loss on 2 meters, 6 dB loss on 70. Just tough, it's the way it is. But Justin in our antennas sent me a couple of antennas. It'd just be nice to put that up there, and I have a continuous 100, I think it's 95 meter run from all the way from the IC 9700 all the way out here, up the pole and to those. And then he's sending me 2 other 50-meter runners to replace the EcoFlex 15, which is currently in the pipe coming out to there, to give me proper waterproof stuff. So we've had a good chat about Coax and everything else, and that's what he'd like to do. So Stefano, if you're watching, thanks for supporting me and the fun I'm having and everything else. All right, so I hope you had a good time. I've had a few aircraft go by. I had a really big aircraft a minute ago, just before I started filming. Maybe you can identify what aircraft it is. It looked from here at 380. I don't know if I can quite get the resolution because I had my phone camera on me. Anyway, a lot of you have really enjoyed following on with this, and there's more to come, I promise you. So in the meantime, enjoy your radio, be creative, right? Get some DX, just play with your radio. It's all good fun, isn't it? All right, in the meantime, all the best now. I'll see you next time. Bye for now.